Today we are going to have a general introduction to relational databases in very simple terms. This is important because BiG Dyads, our flagship database in the BiG lab, is one such relational database, and we intend to build a new relational database, this time an EU Dyads, which is going to be supported by our recently awarded Jean Monnet network. So let us begin. There is something I call relational database hierarchy that will help you a lot in figuring out where things stand when we talk about relational databases. And as social scientists, you must be familiar with at least some of these terms. In this slide, you can see a simplified mapping of them hierarchically, from the building blocks on the left-hand side of the diagram all the way up to the complex that we think of as a database, which is what we get on the right-hand end of the slide. We're going to review these in a bit more depth in the rest of this presentation. The concept of indicator is very familiar to social scientists who want to measure what they study. According to the Social Research Glossary website, quote, "An indicator is an observable and measurable entity that serves to define a concept in a practical way." End of quote. For instance, in Kathleen Stout's Border Inequalities database, which some of you might have heard of, wealth inequality across a dyad can broadly be indicated by a GDP ratio, which we have also used in our BiG Dyads database. Each indicator may directly correspond to a variable, or in certain cases, the indicator may in fact be broken down into multiple variables. Actually, the latter is the case with our BiG Dyads database, which I'm going to explain why in our presentation number 2. Here we see a snippet of 3 rows which contain dyads from the main table of the BiG Dyads database, crossed by a number of columns, each of which stands for an indicator or variable that are part of the same dataset on cross-border inequality mentioned in the previous slide. We can see how the GDP ratio, which can be an indicator for such wealth inequality, is actually made up of 2 independent variables. That is, the GDPs of the neighboring countries whose dyad ID appears in the first column. The reason why some of the columns are grayed out is that they are not part of the database and are only provided here for more info. So what is a variable? At its simplest, a variable, as the name suggests, is something that can vary, or alternatively, a concept that can be measured, or something that can assume different values. The values can be digits, booleans, coordinates, dates, numbers, etc., or textual descriptions that may or may not come from an existing pool of values fixed by the researcher. In this slide, we can see how a variable such as terrestriality, namely being a land or sea dyad, takes on 2 values. And since we have a choice of 2 options here, we can also turn this variable into a binary. For instance, we can fix one, which in Boolean logic stands for true or yes for terrestrial dyads, and 0 standing for its opposite, that is false or no, for maritime ones. And again, on the right hand side, you can see how these play out in another snippet from our BiG Dyads database. Now we get to a very important building block of any database that is of medium scale, dataset. Just let me add in parentheses here that the reason why this is probably the most important part of a database for you is that at the level of data collection, you will be working in effect with individual datasets that make up tables. If you remember the hierarchy diagram I showed earlier in the second slide, these tables in turn come together to form our database. So what is a dataset? At its simplest, a dataset table studies an entity or more than one across a number of indicators. Each dataset row states a fact comprised of indicator-based data points. For example, a dyad described in terms of its geography or history and so on. This table shows the relations between logical categories of a database and their physical implementations or manifestations. Here again, you see a snippet of the BiG Dyads database. So a table is basically a 2-dimensional grid of rows horizontally and columns vertically. These 3 dyads are crossed by 3 variables that are part of the same dataset on conflicts. Once again, remember, the grayed out columns are for your info and not part of the database. Now we can round off the presentation by coming back to the question in our title. What is a relational database? A relational database organizes a number of datasets in relation to one another, hence relational database, and allows for easy and fast accessing, querying, and updating of data stored. This is flat relationality, that is, we have two dimensions only, rows and columns. In another sense, a database can be relational in the sense of multiple tables of data related to one another. Not only are records or rows crossed by attributes or columns, but also can multiple tables be related to one another. So let's visualize real quick how this second sense of non-flat or multidimensional relationality is accomplished. Each record is assigned a unique key as its identifier to preclude duplicates and thus preserve the integrity of a given table. When this key, which is called primary key or PK in its own table, appears in a different table, now it will be called a foreign key or FK and would not have to be unique in the new table anymore. In this slide, the existing primary and foreign keys between these tables are differentiated by the colors yellow, blue, and green. Through the arrangement of these same primary and foreign keys, as you can see an example of here, further relations between different tables, such as these three, can be established, and thus ensure all the tables that make up the entire database are related to one another. Finally, on this last slide, you can find a couple of links for further reading. So if you're interested to know a bit more about relational databases, which is not strictly necessary, you can start with these sources. This is the end of presentation number 1. What is a relational database? Thank you for watching.